Primes and greatest common divisors. 4.3 Introduction. There is an important concept based on divisibility, known as prime number. Prime is an integer greater than 1, which is divisible by no positive integer other than 1 and itself. Definition. An integer p greater than 1 is called prime if the only positive factors of p are 1 and p. But when a positive integer greater than 1 is not prime, is called composite. The integer 7 is prime because its only positive factors are 1 and 7, whereas the integer 9 is a composite because it is divisible by 3. Theorem 1. The fundamental theorem of arithmetic is every integer greater than 1 can be written uniquely as a prime or the product of two or more primes, whereas the prime factors uh, written in the order of non-decreasing size. Example 2. The prime factorization of 100, 641, 999, and 1024 are given by the following solution. 100 is going to be multiple of 2 times 2 times 5, 5, and 641 is going to be equal to 641, and 999 is going to be equal to 3 times 3 times 3 times 37, and 1024 is going to be equal to 2 raised to the power of 10, or 2 multiplied by itself 10 times. If n is a composite integer, then n has a prime divisor less than or equal to square root of n. Example 3. Show that 101 is prime. The only primes not exceeding square root of 101 are 2, 3, 5, and 7, because 101 is not divisible by 2, 3, 5, or 7. The quotient of 101 and each of these integers is not an integer. It follows that 101 is a prime. Example 4. Find the prime factorization of 7007. Solution. 7007 is equal to 7 raised to the power of 2 times 11 times 13. The sieve of Eratosthenes. This is a method of finding Prime's number. Note that the composite integers not exceeding 100 must have a prime factors not exceeding 10, which are 2, 3, 5, or 7. The sieve of Eratosthenes is used to find all primes not exceeding a specified positive integer. For instance, the following procedure is used to find primes not exceeding 100. We begin with the list of all the integers between 1 and 100. So this is the table number 1 used by sieve. The integers divided by 2 other than 2 receive an underline. Integers divisible by 3 other than 3 receive an underline. Integers divisible by 5 other than 5 receive an underline. Integers divisible by 7 other than 7 receive an underline. Integers in blue color, are prime. So now we can This is how Steve went about finding the prime number between 1 and 100. Mersenne primes. There is an ongoing quest to discover larger and larger prime numbers. For almost all the last 300 years, the largest prime known has been an integer of the special form 2 raised to the power p minus 1, where p is a prime number. Example 5. The numbers 2 raised to the power of 2 minus 1 is equal to 3 is Mersenne prime. 2 raised to the power of 3 minus 1 is equal to 7 is Mersenne prime. And 2 raised to the power of 7 minus 1 is equal to 127 is also a Mersenne prime. And 2 raised to the power of 11 minus 1 equal to 2047 is not a Mersenne prime because 2047 is equal to 23 times 89. The largest Mersenne prime known is 2 raised to the power 43, 11, 26, 09 minus 1. Greatest common divisor and least common multiples. The largest integer that divides two integers is greatest common divisor of these integers. Definition: let a and b be integers, not both 0. The largest integer d such that d divides a and d divides b is called the greatest common divisor of a and b. The greatest common divisor of a and b is denoted as GCD-AB. Example 6. What is the greatest common divisor of 24 and 36? The positive common divisor of 24 and 36 is going to be 12, because 12 divides 24 and 12 divides 36, and this is the greatest number we can think of. What is the greatest common divisor of 17 and 22? Well, the greatest common divisor of both numbers is apparently 1. Definitions: the integers a and b are relatively prime if their greatest common divisor is 1. The integers a1, a2, all the way to an are pairwise relatively prime if GCD of ace of I and ace of G is 1. Whenever I and j is between 1 and n. Example 8. Determine whether the integers 10, 17, and 21 are pairwise relatively prime, and whether the integers 10, 19, and 24 are pairwise relatively prime. The GCD of 10 and 17 is 1, GCD of 10 and 21 is 1, GCD of 17 and 21 is 1. We conclude that 10 and 17 and 21 are pairwise relatively prime. Example 9. Because the prime factorization of 120 and 500, for 120 the prime factorization is 2 raised to the power 3 times 3 times 5, and for 500 is equal to 2 raised to the power 2 times 5 times 5 raised to the power 3. The greatest common divisor is GCD of 120 and 500. So now the common factors are 2. So here for 2 we find the minimum, the 2 with the minimum power. that would be 2 raised to the power of 2. And then also 3 is a common between both. So now we have 3 raised to the power of 0 at 500, and then we have 3 raised to the power of 1 at 120. So from here we have, we will take 3 raised to the power of 0. And then also we have 5 is a common factor. So we will take 5 raised to the power of 1 because this is the smaller. And then we multiply those, we get 20. So 20 is the GCD of 120 and 500. So mechanically we can use these methods every time to find GCD if we are confused about finding it. What is the least common multiple of 2 raised to the power of 3, 3 raised to the power of 5, 7 raised to the power of 2, and 2 raised to the power of 4, and 3 raised to the power of 3. The solution LCM of these two numbers. First, we have 2 is common. Now if we take 2 with the highest power, that would be 2 raised to the power of 4. And then 3 is common. We take 3 with the highest power, that would be 3 raised to the power of 5. And then also 7 is common, because on the other hand we have 7 raised to the power of 0, and here we have 7 raised to the power of 2. So we take 7 raised to the power of 2 and we multiply those. That will give us the LCM.